In today's lesson, we are going to be looking at what is a function. So what is a function? So we're going to start off with the definition of a function and then look at some examples of identifying it. So a function is a relation between two variables such that every x value is mapped to exactly one y value. And you might be saying, okay, well, what does that exactly mean? Basically, when we look at a relation or we look at a set of values or an equation or a graph or a table, for every x value, there is only one y value. So if x is 1, then say y and y is say 3, there is only that value of 3 for that x value, right? So when x is 1, y is always going to be 3. It's not going to be anything else, right? So when you plug x into an equation, you're going to get the same value for whatever x is. So if you plug in 1, you're going to get 3. You're not going to get another possible value. So again, that might not make a lot of sense, but hopefully when we look at a couple of examples, it will. So we're going to look at different types of ways that we could represent functions or we could represent relations and see how we can identify whether it is a function or not. So first, what we have are what we call a mapping diagram. So it's similar to a table of values, but sometimes it's more of just kind of seeing when one input is given, what is the output. So for example, the first one, we see that we have different types of cars or different models. So for a Civic, that goes to Honda. Accord goes to Honda. Pilot goes to Honda. The first column, or the first oval, represents the input, or essentially your x values, and the second one represents your output, or your y values. So what we do when we're looking to see if it's a function or not, we say, okay, for every x value, is there only one y value? So for a Civic, is there only one possible answer for that? In which case, yes, for these mapping diagrams or this one here, there's only one possible y value for each of the x values. Now, it might seem a little confusing here because it's all the same y values, but that's okay, right? Different x values can have the same y value, but the y value can't have different x values. So for every x value, there is only one y value. So if we look at these arrows, there's only one value coming out of each x value. So that would make this a function. For the non-example, right, so even though it's already identified as not an example of a function, we can at least see why. So again, the first column is x, the second one would be y, and we can see that from Honda, we have two possible answers, or two possible y values from the one x value. So that means it is not a function, right? Because if we were to enter Honda or input Honda, we have two possible answers that we could get, right? So that is the reason why this is considered not a function, because we have two possible x values or two possible y values for this one x value. Even though for Toyota and Ford, there's only one value, that one x value has two possible values, so it's not a function. Not a function. If we look at, again, more mapping diagrams, so again, an example, even though it's still labeled as an example, we want to just, which tells us it is a function, we just want to make sure we know why. So again, looking at all the x values in the first oval or the first column, we can see that there's only one possible y value for each one. So there's only one arrow coming out of each x value. Even though they could go to the same y value, that's fine, but they don't. There's not more than one arrow coming out of the x values. If we look at the non-example, we can see that for the value of 4, we get 2 or -2 and 2, as well. For the value of 1, we get -1 and 1. So because of those two instances, it is not a function. Because we have different y values for the same x value. So not a function. And again, less numbers in this last example, but again, we can see in the first example, it is a function. Only one possible x value, one possible y value for every x. In the non-example, we can see that when you enter 21, you get either 0 or 1. So two possible y values for one x value, which means it is not a function. So those are mapping diagrams, right? Same can be said for tables. However, the tables might not be, although similar to a mapping diagram, we don't really see it laid out the exact same. So we do have to be careful and see, do I see the x value occurring more than once, right? So if I look at this example, when x is 21, y is 1. When x is 22, y is 0. When x is 45, y is 5. Right? So there's only one value for every x value, or one y value for every x value. So that means that this is a function. If I look at this non-example, right off the bat, I can see that 21 equals 0 and 21 and 1. So I see the same x value occurring more than once in my table. So if I see the same x value occurring more than once in my table, that means there are more than one y value that for a possible x value. So this is not a function. Again, if I look at the next example, we can see that every x value has a different y value, so it is a function. And the non-example, we can see there are different, or actually in this one we don't quite see it, which is fine. So this one is actually an example. This one is actually a function. So we can just cross that off, because looking at it, -1 and 5 is good, 0 and 5, 1 and 5, 2 and 5. We can have different y values. We just don't want to have the same x value coming up. So this is also a function. Looking at the next example, so again, going through the table, do I see the same value occurring more than once? In the x column, I do not. I see -2, 1, 0, 1, 2. I don't even really care what the y values are. For a table, I don't want to see the same x value occurring more than once. So this is a function. And then lastly, actually we don't need to write off. Going back up, sorry, we don't need to erase non-example. We just erase the non part. Next one, again, final one, we can see that we have the same x value occurring more than once in two different values. So 0 we see twice, and 3 we see twice. So that means that those x values have different y values, right? And we only want one possible value for each of those x values. So 0 has two possible options for y, and when x is 3, there's also two possible options. So this is not a function. So moving on from the mapping diagrams and the tables, when we look at graphs, it might not be as easy to see those specific values, right? Because a graph, you might not be able to see the scales, you might not be able to see the full table of values. So there is a different thing that we can do to determine whether it's a function or not. And that is what we call a vertical line test. So a vertical line test is what we can use to determine if, for a graph, if the line represents a function or just a relation. And it's as simple as it sounds. a vertical line. Right? So if a vertical line intersects the graph of the relation at more than one point, the relation is not a function. So if we take a vertical line, run it along our graph, and we see it cross the relation at more than one point, it is not a function, because essentially that means at that specific x value, there is more than one y value. So for example, right, we see our functions in red, or not our functions, our relations in red, sorry. And we can see in the first one, we can see that it crosses, the vertical line crosses our red relation more than once. It crosses twice. So this is not a function. And in our second one, it only crosses, the vertical line only crosses our relation once anywhere you move it. So this is a function. So let's look at some examples using the vertical line test, because that's really probably where you're going to see it. That's probably one of the ones you're more commonly going to use as a test to determine if it's a function or not. So if I look at the first one, now you can use a finger, you can use a pen, a pencil, a ruler, whatever you want, or just visualize it. But I'm going to show you what I mean. So we're going to take this ruler, we're going to make it act as a vertical line. And when we move it across our relation, or this blue line, we can see that our ruler is only touching or crossing the blue line at one point. So for example, if I were to draw my vertical line here, right? Or actually, I'm going to use something that stands out a bit more. So if I were to draw my line here, or say here, I'll use a dotted line. So I did a vertical line test there. I did a vertical line test here. I did one basically anywhere along this graph, and we can see that it passes the vertical line test. It doesn't touch that blue relation more than once. So that means it is a function. If I look at B, same idea, right? I have my vertical line. I'm going to start at one side of my function. I'm going to move it across. It's only touching this relation, or only crossing the relation at one point. We can see the point touching here. Anywhere else I move it to, again, vertical line only crosses once. Doesn't matter where I move it along this relation, it only crosses once. So that means it is a function. Here you can probably guess what's going to happen. I take my vertical line. I draw my vertical line, or I can see that this vertical line has crossed my function, or my relation, in two spots. Right? One up here and one down here. Two spots with the same vertical line. That means it is not a function. So it failed the vertical line test. It is not a function. We have two y values for one possible x value. And again, it doesn't matter where on the graph this occurs, as long as it occurs at least once within a relation, it's not a function. D, again, taking my vertical line, going across. Is it touching more than once? In this case, nope. So there's a vertical line, nothing there. I'll draw one on the other side. Again, you don't need to draw it, but just for visual reference, so looking back, you can see why it passed or failed. So this only touches once anywhere you go, so it is a function. Here, I take my vertical line. These arrows means it continues on forever, but again, if I draw the vertical line, even just at this little bit here, we can see that it touches, we can see that it touches twice, here and here. Doesn't even matter. I don't even care about the other side. I don't need to worry about the other side. It's already touching twice in one spot, so it is not a function. Don't worry about these dotted purple lines here that form an X. Those are what we call asymptotes. So essentially, it's basically saying where the X values do not exist or where this relation does not exist. And lastly, for F, again, probably guess, take a vertical line. We can see it crosses in two spots. So this one is not a function as well. So again, the main thing from this note was just looking at what is the definition of a function, and can we, and given various representations of a relation, can we determine if it's a function or not? So whether it's a mapping diagram, a table of values, or a graph, which we use the vertical line test, can we determine whether a relation is a function or not?